Hello, Maurieo! In this video, Maurieo calcs a curve 2. I'm going to calc another curve. And here's our curve. As we can see, we have got a 18 metre, what looks like a roadway with parallel sides, and we've been given the bearing in this direction and the bearing in this direction as they meet the IP. So the first thing I want to do is to first of all look at the geometry, and we know of course that at the tangent point the radius is always at right angles. So straight away we can put the right angles in here and over here and on the other side of the road of course as well. And then we can calculate the bearings by just adding 90 degrees on. So here I have done the first bearing, 153, 53, 30 plus 90 gives us our 243, 33, 30 for the bearing of A to CP. And I've also added in a few more letters to help with some bits and pieces, like for instance C and D here. And so we can calculate the bearing D to CP. That's just 85 degrees 36 plus 90, which is 175 degrees 36. Obviously I've calculated the bearing around here, added the 90 in around here. Still the same line, it's just the bearing going from CP to D. And now I also drew in the chord from what I've called C to B, because that's going to be quite an important piece, and then also the line from CP to IP, which cuts everything in half but has a certain amount of symmetry about it. So let's calculate the angles of our quadrilateral here, which as it turns out is possibly what's known as a kite. Now I calculate first of all the angle DIPA, which is this angle here. Now over here I've got some diagrams where we put together the bearings so that they're going away from the middle of the angle. So 33 degrees, 33, 30 here, of course the reverse of 153, and 265, 36, the reverse of 85. So we calculate that angle there as 67, 57, 30 by taking these two bearings away here. Now in anticipation I've decided to divide the angle in two, 33, 58, 45, which in fact gives these two angles here, and as it turns out will also give the angle here between the chord and the radius. The next angle to calculate is the angle at CP, that is DCPA. Again, get the bearings going away from the middle of the angle. Sometimes that means adding or subtracting 180 degrees. 63, 33, 30 going that way. 175, 36 down this way. Here I am taking the two angles away, just putting it slightly smaller so I can fit it on the page, and I get a total angle through there 112, 02 minutes 30, which I then divide by 2 to give me 56 degrees 01 15, which is this angle here and here, the half the total angle. You will also note that it's complementary, or that they add to 90 degrees. 33, 58, 45 plus 56, 01 15 adds up to 90. So that's a pretty good sign that all things are good so far. And so now we're going to move ahead and calculate a little bit more. Alright, moving on, we're now going to calculate the coordinates of C. We have the coordinates of A, we have the bearing 243, 33, 30, and we know that the road's 18 metres wide, so we can calculate the coordinate of C quite easily. and here I'll just get the 15C calculator up. I've got that coordinate written out. So first thing to do is just to clear the sigma key, put in 300, enter, 700 sigma plus, and then 243.333 2 hours, 18 to rectangular sigma plus, recall sigma plus, and there we have our northing 691,985 and XY that 283,883. Now the next step in the line is to calculate the chord C to B, or C as I have labelled it, and seeing we've already got the coordinate of B determined, and we know that C is this coordinate here, all it remains to do is to key this in 272. Note we're going 0.848, enter. Note we're going easting first. I'm just checking a coordinate here as well, 672.543, and we just go sigma minus to that. That may well calculate the bearing in the opposite direction to what we want it, but that doesn't really matter. And then we just recall sigma plus, and that's in rectangular, so we want it in polar, and there's our distance, 22.355, XY 2 hours, minutes and seconds, 39, 34, 44. So that's calculated, we'll just put that away for now, that's calculated our chord across here. Now when we've calculated our chord, we also know that we separate the triangles in half, and that will give half the chord on each side there of this separation line. So dividing the total CB that we've just calculated in half, we get 11.1775. I've kept the other decimal place there just to try and keep things as accurate as possible. Now that gives us this little triangle here, of course, which the radius C to CP, the radius there is also equal to B to CP, and that's in a right angle triangle, which I don't think we need to do too much explanation on, but let's just say that sine 56 degrees 0115, which is our calculation here, divided is equal to 11.1175 divided by the distance C to CP, and manipulating that equation we get C to CP equals 11.1775 divided by sine 560115, which gives us the answer 13.479, and that is our radius. That is the radius from CP to B. That was one of the required quantities that we wanted to work out. So it now remains to proceed on and calculate the coordinates of IP. Alright, now to calculate the coordinates of the IP, we need to take out the triangle CPAIP and calculate the distance A to IP. Now we know that this C to A is 18. We've just calculated the distance here, 13.479. You will note that I said that the bearing C to B was 39. It is in fact 29. I misread that, but I had it written correctly on the bit of paper there. So just tidying that up, just in case you thought I was something had gone awry. I just misread the number. Now, so we have a total distance through there of 18 plus 13.479, 31.479. We know our angles, which we've calculated earlier, so it just remains to calculate A to IP. And tan 3358.45 is equal to 31.479, the opposite, over A to IP. So A to IP is 31.479 tan 3358.45, which gives us 46.706, which I've now written here on the diagram. And what we want to do is we want to calculate the coordinates of the IP. So I've written out a little close, which would be very good, self-checking if this comes out. So I've gone from A to IP to D and back to B, which we know the coordinates of. So first of all, we write out our coordinates, and here we go. Let's get the HP 15C back, and let's just work through this close here. We can put the calculator up there. So first thing, clear the sigma key, put our 300 in by 700, sigma plus, put that one in, 153.333, convert that to hours, 46.706, convert that to rectangular, sigma plus that, recall sigma plus, 658.180, xy 320.798, and we continue on, 265.36 to hours, 46.706 to rectangular, sigma plus, recall sigma plus, 654.597, 274.229. So on the last leg now, 355.36 to hours, 18 to rectangular, sigma plus, recall sigma plus, 672.544, which is 1 mil out in the northing. I'm going to accept that. XY 672.848, spot on for the easting. So that's a good close around there with the HP 15C. I think that's a good check on everything. Quite happy with that. And then underline the coordinate of the IP and write it up here as I have for the answers. Just by way of setting out, my setting out is pretty much governed by the amount of room that I have and how I explain things. So with where you've got more paper to use and you can have sheets of paper side by side, you should be able to achieve a slightly better and more professional looking set out than I have done here. And I hope you understand that my set out is, I've got limited room, and I'm trying to keep things for minimizing time with my videos and what have you. But there you are, another curve calculated.